Hi there, this video is about how you make an ionic compound. Now I'm going to draw a picture that's going to cover this whole screen, but since I'm on a computer screen, I can't really write as small as I would normally like to. So a lot of things I say I won't be able to write on the screen because I'll run out of room. So you'll have to listen to my words too and write those things down, as I won't be able to write everything. Okay. So this video is going to talk to you about how we make an ionic compound. An ionic compound is made when we take a metal plus a nonmetal and put them together. They form a special bond called an ionic bond. Let's try to make this skinnier. And so when a metal and nonmetal come together, they make an ionic compound. I'm going to make the most classic compound, NaCl, sodium chloride, which is table salt. So what I'm going to do is take the Na atom and hook it up to a chlorine atom. So first thing we're going to do is actually draw an Na atom. If I take a look at Na or sodium, he's number 11 on the periodic table, and I'm going to write his electron configuration, and it goes 1s2, 2s2, 2p6, 3s1, which means he has 3 energy levels. Now normally when we draw this, we would draw the atom with one circle for the 1s, then there's the 2s, then you got the 2p's, then you got the 3s. But it's really hard to see the electrons in there and things get all funky. So how I'm going to draw it is with the Bohr model. The Bohr model allows us to see rings, although we know that technically there are no orbits, there's orbitals, but we can kind of go with that. So here's my nucleus, and I still need 3 energy levels, 1, 2, 3. On the first energy level, I happen to have 2 electrons. On the second energy level, I happen to have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 2 in the S and 6 in the P. And then on the last energy level, I have 1 electron. So this is my picture of what the atom kind of looks like. Now if I do a proton to electron count, since that's number 11 on the periodic table, it has 11 electrons. And since it's number 11 on the periodic table, it has 11 protons. 11 protons and 11 electrons, if you add those two up, you get a neutral atom. It has no charge. Okay, let's kind of do the same thing over here for chlorine. Chlorine is number 17 on the periodic table, so if I write its electron configuration, it goes 1s2, 2s2, 2p6, 3s2, 3p5. If I draw its diagram, I would have 3 rings for this also. Here's my nucleus, 1, 2, 3 rings. On the first ring I happen to have 2 electrons, 1, 2. On the second ring I happen to have 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. And on the third ring I have 7 electrons, 1, 2, 3, 4, 5, 6, 7. Okay, if I do my proton to electron count, I have a total of 17 electrons. It's number 17 on the periodic table, which means I also have 17 protons. If I add those two up, 17 and 17 is going to get me a neutral charge, or no charge. Okay, so these are my 2 atoms. Now, they're not going to just automatically make an ionic compound. They won't stick together like magic. What they're going to need to do is do something between each other. So currently these atoms actually aren't called stable. Stable means you don't want to react with anyone. Well, chlorine atoms really want to react with something, and sodium atoms really want to react with things too. And it has to do with what we covered last chapter, which is about electronegativity and ionization energy. So let's think about the chlorine atom versus my sodium atom. If you take a look at the periodic table, you'll see that chlorine is more in upper and to the right. Anything close to fluorine is the most electronegative, is very electronegative. Chlorine has a high electronegativity. Check your notes on electronegativity if you don't believe me. Which, in comparison, means sodium has a really low electronegativity. Electronegativity is technically defined as the amount of attraction, or the ability of an atom to attract electrons to itself, or as I like to call it, is how much you love electrons. Chlorine really loves electrons. And sodium, he doesn't like electrons. I'm going to say he hates electrons. This correlates to the idea of ionization energy. We know that sodium has a low electronegativity, which also means he has a really low ionization energy. It's easy to remove an electron. Chlorine, on the other hand, has a really high ionization energy. It's really hard to remove an electron. So between the two here, since sodium hates electrons and chlorine loves electrons, what they're going to do is transfer electrons between the two. Here's how it happens. Sodium over here, remember we talked about metal reactivity? Metals, in order to react, need to lose their electrons. That's exactly what happens. Sodium takes this outer electron here, and this is the electron he loses. He's going to lose 1 electron, which he's fine with because he hates them anyway, so it seems like a good idea to him. So when he loses an electron, let's redraw what he looks like. He's got his nucleus, but now we only need 1, 2. Notice that I drew them smaller and closer together. If you've got one less ring, it should be smaller. And if you have one less ring and more protons and electrons, it should also be smaller. So this is definitely, I'm trying to draw a smaller circles than I had before. We'll draw its electron configuration. 1s2, 2s2, 2p6, and now my 3s1 is the electron that gets lost. Let's take a closer look at this electron configuration. This right here, if I did the shorthand for sodium, would be neon 3s1. Now, I really only have neon left. So the question is, did I actually make neon? Is this a picture of neon? And the answer is no. I know this because if I look, I still have 11 protons. I didn't change the number of protons that I have. But I did change the number of electrons. I went down by 1, so I have only 10 electrons. If I have 11 positive and 10 negative, I end up with a 1 plus charge. I know that this is not neon because it has 11 protons. Neon is number 10 on the periodic table, so it has 10 protons. This is not neon because it has 11 protons. The electrons and where they're located, their configuration, looks like neon, but it surely is not. What this really is called the Na, or sodium ion. Ion is a special word that stands for charged particle. That's what it's defined as. Charged particle is an ion. Okay, so we can see that this is smaller for 2 reasons. 1, we lost an energy level. The third energy level is completely gone. And 2, here's where I don't have a lot of space to write this stuff, we can see that we've got a proton to electron ratio that's different. We have more protons than electrons. More protons means more positive stuff that can hold in the remaining electrons. They can hold those in a little bit tighter. I forgot to put my electrons in. 2 in this part, and there's 8 in the outer part. 1, 2, 3, 4, 5, 6, 7, 8. Did I get that? 1, 2, 3, 4, 5, 6, 7. There we go, 8. 8 electrons. Now, why would sodium ever want to do this? Sodium does this for a very important reason. If you take a look at the atom over here, the fact that he has 1 electron, this one outer electron is called a valence electron. It's an outer shell electron. Now every atom out there would prefer to have a full outer shell. Notice with the sodium atom he has 1 valence electron, so he doesn't have a full outer shell. A full outer shell would follow the octet rule. Now if you take a look at my sodium ion, he has 8 electrons in the outer ring. 8 electrons in the outer ring means it has a full octet. It follows the octet rule. And the octet rule is what every atom wants to do. The noble gases have 8 electrons in the outer ring, and they follow the octet rule. That's why noble gases don't react with anything. But everybody else, well, they need 8 electrons, so they need to lose or gain electrons to get there. Okay, now let's think about this for a second. We have lost our electron from sodium, and where did he go? Over here to chlorine. Chlorine gains 1 electron. He would love to gain an electron because he loves electrons. He has a high electronegativity, and he would love to have them. This is supposed to be a heart. Wow, that's a terrible heart. Okay, so if he gains an electron, here's his nucleus. Now he's got more electrons than protons, so I've got to draw his 3 rings bigger than I did before. 2 electrons in the center. 3, 4, 5, 6, 7, 8. 8 electrons in the second ring, and 1, 2, 3, 4, 5, 6, 7, 8 electrons in the third ring. This last electron he gained from sodium. That 1 electron that he gained. So if I look at my electron configuration now, I've got 1s2, 2s2, 2p6, 3s2, 3p6. If I do the shorthand for this sort of thing, I can see, oh, not the 3s. Sorry, just up to the 2p. That would be neon, 3s2, 3p5, and this whole thing over here is a full outer shell because it gained 1 from chlorine, gets me to argon. So the question is this argon or is it not? It is not argon for the same reason that the sodium ion is not neon. Argon has a total of 18 protons, and this one has a total of 17 protons still. It has 18 electrons, so it looks in electron configuration that it's argon, but it really isn't. It is a 1 minus charge, since there are more electrons than protons. And this is called the chlorine ion, charged particle. I drew it bigger because there are more protons, or there are more electrons than protons, so it's hard to hold on to. Fewer things we've got to put in here. I hope my time doesn't get up. So why did we kind of do this all? Well, we're trying to create an ionic compound. An ionic compound is held by an ionic bond. If you take a look at this ion right here, it is a +1 charge, and it's going to be really attracted to this ion over here, which is a -1 charge. These two circles are attracted to each other, called an ionic bond. It's the attraction of two ions, or ions in general. We can have more than two ions. So it's the attraction of ions. That's what an ionic bond is, and that's what holds. It's like a magnet that holds the ionic compound together. Another thing to add in here are a couple terms. If you happen to have a positive ion, it is called a cation. It looks like cation, but it's cation. If you are a negative ion, like the chlorine ion over here, it's called an anion. Here's how you can remember it. Anion really kind of looks like onion, and onions make you cry. That's negative. Or you think about cations. Cats, they're beautiful creatures. They make a lot of people very happy. Cats are positive creatures. Or my third way to remember it is cats have paws. Positive cations. Hopefully that helps. Okay, I'm getting low on time here. Fewer things to cover. Lewis dot structures. So all this stuff that I've drawn is pretty complex, and it's a lot to draw. So this guy named Lewis, he's one of the chem gods, decided that that's a lot to do. So let's try and simplify things. Here's how he drew the sodium atom. He draws it as sodium with 1 dot on the outside because that's its 1 valence electron. Kind of like over here. Here's chlorine. Oop. Watch carefully as I put it in. He has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Notice I went around in the circle. It really doesn't matter where you start your circle, from the bottom, the side, or the top. But I only added 1 electron at a time on each side and then started doubling up, just like an electron configuration. Don't double up till you have to. Now when we create the ions, sodium has lost his valence electron. It's not there anymore, so I don't draw any dots, but I do draw the 1+ charge. And chlorine over here comes with 7. 1, 2, 3, 4, 5, 6, 7. And then he gains 1 electron. We show the gained electron is a triangle. Put some brackets around there, give it a 1- charge. That says there's 1 triangle in there. The triangle means, hey, I'm an electron, but I came from somebody else. In this case, I came from sodium. It really doesn't matter where you put your single dot. If you just turn your paper around, the single dot moves from the top to the bottom to the side, so you can have your single dot any place you want. There's no big rules, because you can always turn the paper, and Lewis is cool with that. So, that is the story of it. I'm going to take a quick look at my notes, make sure I got everything. Yeah, I don't think I missed anything. So, there you go. What you could do is I'm going to put this picture online, so you could print off this picture and kind of add things to it. And hopefully that'll help you for your notes. Come see me for questions.